Alright, so this question says the following table is the energy level and amount of energy an electron has at that level for a hydrogen atom. So basically, if you think about a hydrogen atom, I'll draw it. You have a proton, and you have these different energy levels. 1, 2, 3, 4, 5. Now, an electron can be in any one of these energy levels. It could be there, it could be here, it could be here, it could be here, or it could be there. Now, an electron at this energy level right here has an energy of 13.6 electron volts. Now, that's 13.6 electron volts lower than an electron that would be way out here. This electron over here would be like ionized. This electron right here would be 13.6 eV lower energy than this electron out here. Okay. The second electron has an energy level of 3.39 electron volts lower, and then the third one is going to be 1.51, 0.85, and 0.54. It means that this electron right here, it only takes 0.54 electron volts to remove it to make it ionized, to make it leave, essentially. So, yeah, there's all that. I'm going to erase all this. So what we're going to do is try to answer some of these questions here based off of the quantum physics homework. So how many possible energy transformations are there? Well, energy transformations happen when you take an electron from a higher energy level, such as like n equals 5, and jump it down to a lower energy level, like n equals 4, or n equals 3, or 2, or 1. So I'm going to go through all the transformations possible. An electron could start at energy level 5 and jump down to 4. That will produce a value of, well, it started at 0.54 eV and it went down to 0.85 eV. So that'd be a difference of 0.31 electron volts of energy needed to jump that gap. It could start off at n equals 5 and jump down to n equals 3, which means it would start at 0.54 and it would go to 1.51, which gives a value of 0.97 eV, which is a different amount. Now, basically, what's going to happen here is that you have all these different transformations, and each transformation is a different amount of energy being released. So I'm going to try to name them off for you. So you have to start from high and go on to low. So you have one that goes from 5 down to 4. Then you can start at 5 and jump down to 3. Then you can start at 5 and jump down to 2. Then you can start at 5 and jump down to 1. Those are all possible. An electron could potentially be in the 4th energy level and jump down to the 3rd one. It could be in the 4th one and jump down to the 2nd one. It could start in the 4th and then the 1st one. An electron could start in the 3rd one and jump down to the 2nd one. It could start in the 3rd one and jump down to the 1st one. And finally, an electron could jump from the 2nd one to the 1st one. So that gives a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possible transformations that this electron could use. And all of these transformations have a different amount of energy. And the way you find out how much energy it takes is you take the energy of whatever transformations it started with and subtract off energy that it ended with. So this would be like the energy transformation from 5 to 2, for example. Alright, now for the next question, it says calculate the maximum energy in electron volts that can be released and the frequency of the photon emitted. Well, the maximum energy that could be released would be if it started in the 1st energy level and it got completely removed, which has 0 eV. So the maximum energy would be just 13.6 electron volts minus 0, because that's the energy when it's completely gone, which is 13.6 eV. Sorry, my bad. 13.6 eV. Now, what we can do is we can convert that electron volts into joules, because 1 electron volt is equal to 1.6 times 10 to the 19th joules. So what we'd have to do is take 13.6 and we would have to multiply by 1.6 times 10 to the 19th joules per electron volt. We're going to get a pretty small number for the joules, but that small number will be the energy in joules needed to remove the electron from the lowest energy level. We'll get something like 10 to the 18th to